Welcome to Study Loop.
For our question, we're told that the radius of curvature r is equal to 15 centimeters and v0, the velocity of the object, is equal to 5 centimeters per second. And it wants us to find a relationship for the velocity of the image as shown in the question. So to do that, we're going to start with our equation, which says that 1 over the distance to the image, I, plus 1 over the distance to the object, P, is equal to 1 over the focal length, F, or 2 divided by the radius of curvature, r. And we're asked to put things in terms of r, so let's go ahead and write the expression this way. So we can solve for I, and we see that I is equal to P times r divided by 2 times P minus r over 2. We can simplify this a little bit further, and we find that I is equal to P times R divided by 2P minus R. So I just distributed that 2 all the way through. Okay, so now let's take the derivative, because the velocity is the derivative with respect to time. So di by dt, the derivative of I with respect to t, is equal to the velocity of the image. So this is equal to what we're going to call v of I, which is what we're asked to solve for in the expression. So this is equal to the derivative d by dt of what's on the right side of the equation, which is p times r divided by 2p minus r. Well, the derivative of r with respect to time is 0 because there's no time dependence there. It's p that changes with respect to time. So taking the derivative of this, we find that this is equal to r divided by 2p minus r squared multiplied by the derivative of what's inside, which was dp by dt. But dp by dt is the velocity of the object. So what we find here is v sub I is equal to r divided by, I had a misprint here. This is supposed to be 2p minus r, not 2p times r. So this is 2p minus r. So r divided by 2p minus r, that whole thing squared, multiplied by dp by dt, which is the velocity of the object, which we called v sub o. And this is what we were asked to prove for part A, so we can go ahead and box all of that in as our solution for part A. Now we know r and we know the velocity of the object. And then for part B, it says, okay, well, now let's consider a situation where the distance P is equal to 30 centimeters. And it says, okay, well, if P is equal to 30 centimeters, what's the velocity of I? So you just have to plug that P into the expression we found for V sub I, as well as the value for R and V sub O. We find that V is equal to 0.56 centimeters per second. We can box that in as our solution for B. So it starts out pretty slow. Then C, it says, now let's consider when P is equal to 8 centimeters. So it's getting a little bit closer here. So we plug in 8 centimeters into our expression, as well as all the other values we know. And we find that V sub I is equal to 1,125 centimeters per second, or approximately 1,100, because we're doing 2 significant digits, approximately 1,100 centimeters per second. Well, actually, let's go ahead and write the exact value. So this is 1,125 centimeters per second. But if we're doing 2 significant digits, we say that this is approximately 1.1 times 10 to the third centimeters per second. And we can box it in as our solution for C. And then finally, so it's starting to get really fast here. And then finally, part D, it's really close. We're going to say that P is equal to 10 millimeters, which is 0.1 centimeters. We'll keep everything in units of centimeters to be self-consistent. Plugging that value in, we find that V sub I is equal to 6.7 centimeters. So it starts slow, speeds up to really, really fast, and then slows back down as it gets closer to the actual mirror. We'll box that in as our solution for part D.